A chip that can only run one thing just raised $300 million at a $10.3 billion valuation. Etched has over $1 billion in signed customer contracts, and the company says its silicon worked on the first try. The engineering here is real. The number everybody quotes about it is not what you think it is. Start with the risk, not the pitch. Etched filed its architecture patent in June 2023. First rack ships summer 2026. 3 years. 3 years is the real constraint on custom silicon. A leading-edge design runs $200 to $400 million in engineering before a single wafer moves. And once the finished design reaches the foundry, silicon still takes 12 to 20 weeks to come back. So a transformer-only chip is a wager. It bets the transformer stays dominant longer than it takes to design, build, and pay off. Give them this. Etched reports first pass silicon success. No res pin. In custom silicon, that is the hardest thing to do, and they cleared it. Racks are scheduled for this summer, though no customer delivery has been confirmed. Now the pitch. On July 23rd, Etched raised $300 million led by Sequoia Capital at a $10.3 billion valuation. That roughly doubled the company's valuation in 7 months. The $5 billion figure people still quote is from December, and it is already stale. One investor in that round is worth naming. SK Hynix manufactures high-bandwidth memory. Sohu's entire design depends on it. The memory supplier now holds equity in the chip company that needs its memory. The chip itself is fabricated by TSMC on its N4P process. An independent teardown puts it at roughly a reticle limit die, paired through an interposer with 6 stacks of HBM3E memory, 144 gigabytes. Hold that number. Etched names 2 technologies: low-voltage inference and cluster-scale memory, a hybrid SRAM and HBM subsystem scoped to a whole cluster. Neither one arrives with a single published number. Remember cluster-scale memory, though. It matters later. To judge the bet, you need one mechanism. Inference runs in 2 phases. Prefill reads your entire prompt at once. Decode writes the answer back 1 token at a time. Prefill is compute-bound. Arithmetic intensity runs 200 to 400 operations for every byte moved. The hardware is genuinely busy. Decode is a different machine. For every token it produces, the model reads the entire key value cache back out of memory. Intensity collapses to 60 to 80 operations per byte. The compute units sit there, waiting on the memory bus. A peer-reviewed study measured the cost. Across every model tested, more than half of all attention cycles stalled waiting on data. And no model exceeded 35% average compute utilization in either phase. 2/3 of the machine sits idle. And before you say, just use bigger batches, the same study found the attention kernel's intensity stays almost flat as batch size climbs. It stays memory-bound the whole way up. That idle time is the prize, and everything Etched claims is an attempt to collect it. So where does specialization find that time? The patent claims 2 engines in parallel. A systolic array for operations independent of previous tokens. A separate circuit for attention, which depends on them. And each engine gets its own high-bandwidth memory channel. Wait reads and cache token state stop fighting each other for the same path. That contention is a real cost on a general-purpose part. One caveat for the patent readers. The filing leaves that attention element generically defined, so transformer only is Etched's product decision more than a hard limit of the silicon. Every workload the company describes is still a transformer. The patent states the case plainly. An n-by-n systolic array computes 2 n-squared operations per clock, needing only 2 n inputs. Read that again. Compute grows with the square of the array. The data you have to feed it grows in a straight line. That gap is the entire prize in specialized silicon. An independent teardown reconstructs it from 3 parts. 3 times from reallocating silicon, 3 times from utilization, 2 from running both engines at once. Multiply those together and you get about 18, not 20. The analyst calls that close enough given how little Etched has published, which is the tell. This is a number being reverse-engineered, not verified. Which is the honest version of that headline, not magic. An arithmetic stack of 3 separable effects, each of which you can argue with. Now the number itself. Etched claims 8 Sohu chips sustain more than 500,000 Llama 70B tokens per second, against roughly 23,000 for 8 H100s. Hold that up to the light. There are 2 problems with it, and the second one decides the whole argument. First problem. That figure comes from the 2024 launch materials. As of today, Etched's own website publishes no benchmark at all. No tokens per second. No GPU comparison. Nothing. What the site does say is state-of-the-art throughput, unquantified, and that performance updates are coming this summer. There is still no third-party benchmark. No ML-perf submission. Every number in circulation traces back to the company. Second problem, and the bigger one. That number assumes 8-bit precision, 2048 input tokens, and very high batch. Sure context. Enormous batch. Now run that server at 8,000 tokens of context, batch 1,000. The cache alone needs about 1,280 gigabytes. 8 chips at 144 gigabytes hold 1152. It runs out of memory before it runs out of compute. So the claim is not false. It is true inside a shape that is not a chat application and not an agent doing long context work. And Etched has an answer to this, which deserves saying out loud. Cluster-scale memory pools memory across an entire cluster rather than one chip, which attacks precisely this ceiling. They have simply published no number for it yet. One more comparison decides this. AWS Trainium 3, 144 gigabytes at 4.9 terabytes. Google's Ironwood, 192 gigabytes at 7.37. The independent estimate for Sohu, 144 gigabytes at about 4.8. The specialist does not win on memory. And both of those also train. Note the evidence gap too. The Google and AWS figures are published vendor spec sheets. The Sohu figure is an outside estimate, because Etched publishes no specifications at all. Which means Sohu's advantage cannot be coming from its memory system, because it does not have a better one. It rests entirely on utilization and data flow. Which is exactly what the patent claimed, and exactly what the research says is sitting there and used. So, the bet is 3 years of silicon against the transformer staying dominant, and Etched cleared the hardest part of it on the first try. The order book is over $1 billion, and the memory supplier bought in. But the headline number is 2 years old, unaudited, and true only at short context and enormous batch. On memory, chips that also train already match it. This is a real bet on a narrow claim, not a GPU killer. Before you believe any multiple, ask what context length it was measured at. Sources are on screen. Follow Inference Wire for what the AI headlines actually mean.